Alright guys, welcome to the 7th page of 8, so we're almost done, of our quarter 3 review. Let's go ahead and do some more factoring. Okay, let's check this out. So even though it's x to the 4th, x squared 12, there's still 3 terms. Always check if you can take out a greatest common factor, and it doesn't look like it. So I'm going to go ahead and I'm actually going to do our tree method as before. We want 12 and we want negative 7x squared. So we know x squared times x squared equals x to the 4th. And now I need two numbers that'll multiply to give us 12. So I'm going to do, let's see, 3 and 4. That's positive 12. If I multiply going down, we get 3x squared plus 4x squared. But that's not negative 7x squared. It's positive. So if it's positive but we want negative, I'm going to make them both negative, which means these have to change to be negative, which is still okay because a negative times a negative is positive. And now this works out. So the factors are the diagonals. So we get x squared minus 4 and x squared minus 3, but it says factor completely, and x squared minus 4 is a perfect square root. So this guy can actually factor again to x plus 2 and x minus 2, but the square root of 3 is a decimal, so that stays as x squared minus 3. So now we're officially done. Okay, we have 3 factors actually. Our next one, the biggest mistake people do is they're like, oh, well, the square root of 100 is 10. We can apply the same rule. But this is difference. This is sum. And that doesn't work. So if you have x squared plus a number, and it's square root and you can't take out a GCF, this is not factorable. Or D and F does not factor. The next one though, it's subtraction, so we're still good. And we notice the square root of 16 is 4, and the square root of 49 is 7. So if that happens, then we can do the following. We can do 4x and 7, 4x and 7, one positive version, one negative. The only reason we can do that is because there's 2 terms with a difference, a subtraction, and they're both perfect square roots. That's the only reason why we can factor it as such. Next up, we have another adding rational expressions, just like on the previous page. I'm going to go ahead and I'm going to factor the denominators, which in this case, we only need to do it to one part, this. So that becomes x and x, 2 and 2, plus and plus. Awesome. Let's look. They both have an x plus 2. This one has an extra x plus 2. So this one, we have to multiply the other missing part, because the goal is to have the same denominator. So if I say equals, I can go ahead and I can write it all as one big fraction, because now that they have the same denominator, I can only need to write it once. Let's wait for the video to catch up. I don't know why it does that. Oh well. Now we distribute. So on the top we have x plus 2 plus 2x plus 4. And I can go ahead and combine any like terms on the top. So this becomes 3x plus 6. I can actually take out a 3 here, and that's an x plus 2. And now we notice the x plus 2's cancel. So I know it's weird the direction I'm going in, but the final answer is 3 over x plus 2. Again, the only reason we could do that is because 3 and 6, the greatest common factor is 3. I can take it out, factor it out. Next up is solving, and for solving, you can do it with a calculator, you can do it with Desmos. Honestly, I think a calculator would be best because then you can just do the table. Again, like in the other video I mentioned, I don't have a graphing calculator on me at the moment, so I'm going to go ahead and I'm going to use Desmos. It's the same process though. Your first line on Desmos is the left side of your equal sign. And if you're using a graphing calculator, y1 is going to be the left side of your calculator. So we're going to do y equals 1 plus, and if you want to make that dividing sign on Desmos, you just hit the dividing button. Oops, I don't know if you guys saw that, but I hit this dividing button, and we got this fraction, and it's 1 over x. Okay, there's the first one. And then on the second line, or in y2, depending if you have a calculator or Desmos, we put the right side of the equal sign. So that's 72 divided by x squared. Now we look for where they intersect. So they actually intersect at 8 and -9. So if we look at our options, 8 and -9 is where they intersect, and that's their solution. It's always the x values that we care about, because it's x equals. So next up, we do the exact same process. It's great that it's multiple choice. So I'm going to go ahead and clear this. That's y equals, everything on the left side goes on the first line. So that's 1 over x plus 6. Out here we have plus another fraction, that's 3 over x plus 4. And then on our second line, or in y2, we put everything on the right side of our equal sign. So I'm going to put divided, -2 over x squared plus 10x plus 24. Now if you're using a calculator, you are not going to get these fraction bars unless you have like the newer edition, so you have to put parentheses. So for example, if I were to put this in my calculator, I would do 1 divided by x plus 6. Then I would do plus 3 divided by x plus 4. That would be my y1 equals in your graphing calculator. Okay? And then you would do the same thing for y2. Put your parentheses around those guys. But Desmos, the easy part, we don't need to do that. And I can go ahead and look for where they intersect. Since it's kind of hard to see with these rational functions, that's when it being multiple choice comes in handy. So we have a couple options. We have 4, and it doesn't look like they intersect at 4. See, they're too far out. We can try 0, but 0, they don't intersect. We can try -6 maybe. Let's see. This is a little tricky. Where is -6? I've lost it. Let's go back to the home screen. Okay. Might not actually intersect. Well, if we put in -6, we'll get an error on one of them. So that's not it. So I guess for this one, I could be wrong. But for right now, I'm going to say no solution. Because it doesn't look like they actually ever intersect. And there's an asymptote at -6, which means there should be no value at x equals -6. So I'm going to say no solution for that one. Okay. Next up, it's just a simple question. How do we find inverses? And it's always you switch x and y values. I'm going to go ahead and I'm going to star that because it's so simple, yet It's the first thing everyone forgets. Okay. So we got one more page to go. I'm actually going to keep it in this video, and we're going to move on. Oh, there's the cat. Hello. Hi, baby. He's attempting to help. That's okay. Let's do the 8th page as well. So here we have a graph. Okay, might look familiar. And ooh, we don't bite the screen. Based on the graph, we know it's a 6th degree, and we have to put it in factored form. So for factored, I'm sorry guys, but it's what it is. Alright, so factored form, we know we're going to look at the x-intercepts here. So it goes through 0, so we have to make sure they all have an x, which they do. Then we have something at 3, and if it's at x equals 3, the factored form is x minus 3, because if we want it to equal 0, and I want to move the 3 over, it's positive 3, and I do the opposite, becomes x minus 3 equals 0. And there's our factor. So it's like a reverse algebra going back and forth. So we need an x minus 3, which they all have. And there's something at negative 2. And if it's at negative 2, then the factor is going to be at x plus 2. After that, we're going to go ahead and notice that some of these have exponents. Key is, at 3, we have a bounce. And a bounce is exactly what it looks like. We touch the x-axis, and then we bounce back up. So we don't physically go through it. When you have a bounce, it's a multiplicity of 2. So we have something being squared. So at x minus 3, we need a square, which means we've now eliminated option A and option D. Those are now out of the picture. Okay. At 0, it just goes through. So at 0, there's no exponent, which is why they have just the x's. The next one, it has like a weird curve. So if we look, it goes, it flattens out, and then it keeps going. So whenever you have this shape, or the opposite direction, this shape, that's an inflection point. And if you have a shape like that, it's actually to the 3rd power. So it's a multiplicity of 3. That just means exponent of 3. So at x equals negative 2, so at x plus 2, there has to be an exponent of a 3, which means the only option we have that has all of those is option B. Next up, we have a square root function. So what is the function below? Since it's multiple choice, honestly, you could put each option into Desmos or your calculator and see which one matches up correctly. Okay. If you wanted to figure it out by hand, then if this is at negative 3, I know in the square root, it should be the opposite. It should be a plus 3. So we have a plus 3 here. That's negative, so that's out. That's plus, that's fine, that's negative, so that's out. So now it's the difference between positive and negative. And if we wanted to, we could pick a point. So if I plug in x equals 1, so let's do square root of 1 plus 3. That's the square root of 4, which is positive 2, which is here. So that means it's option C. Because if I had negative, it would have been negative 2. And that's not where the picture is. Right? 1, negative 2 is here, and that's not where the graph is. So if it was negative, it would be down here. So that's why C is our answer. I know that was a lot if you've watched every page, every video, but hopefully this has helped you guys study, and you now know what you need to go back and really focus on and what things you're more strongly in. You even got to see a little bit of juju, this is what happens when you watch the videos. Good luck studying. If you have any questions, make sure you go see your teacher or other videos from Khan Academy for help. Okay? Have a great day or night, depending on when you watch this, and we'll see you guys in class.